Let's get comfortable with these arc functions by evaluating inverse sine and inverse cosine at a few important points. So keep in mind that the inverse sine function has outputs that are angles between negative pi over 2 and pi over 2. And arc cosine has outputs that are angles between 0 and pi. So in this first example, we're looking for the inverse sine of 1. That is, what we want to know is for what angle theta is sine of theta equal to 1, where theta lives between negative pi over 2 and pi over 2. Okay, and if we think back to these functions, we know that this happens when theta is equal to pi over 2. Okay, let's next try inverse sine of negative 1. So what we want to know is what is sine, so for what angle theta is sine theta equal to negative 1, where again, theta is between negative pi over 2 and pi over 2. And this is going to happen at the angle theta equals negative pi over 2. Rephrasing like this is a little bit easier to think about. So if we're looking at inverse cosine of 1, the problem we want to know is at what angle is cosine of theta equal to 1, where we say that our angle needs to live between 0 and pi. Okay. Luckily, we know that angle. That angle is going to be theta equals 0, and so the inverse cosine of 1 is equal to 0. For this fourth problem, the inverse cosine of negative 1, we know cosine has output of negative 1, and we want to know the angle that gives us that output. We want our angle to live between 0 and pi. If we think about the graph of cosine, between 0 and pi, we have output of negative 1 exactly at pi. So inverse cosine of negative 1 is equal to pi. Okay, sine inverse of 0, take a moment, try this out. I'd like you to try these next 4, and then we'll go over them. Okay, the inverse sine of 0, we want to know the angle theta, where sine of theta is equal to 0. This happens when theta equals 0. Okay, the inverse sine of negative 1/2. We want to know the angle theta between negative pi over 2 and pi over 2, where sine of theta is equal to negative 1/2. This is going to be theta equals negative pi over 6. Okay, next up we have the inverse cosine of 0. So the other problem that we're going to solve instead is cosine of theta equals 0, where theta is between 0 and pi. And this happens when theta is equal to pi over 2. So these values of the trig functions we want to either memorize or be able to produce. So for example, if you wanted to take a look at the graph we have here, we check to see for what angle between 0 and pi is cosine theta equal to 0. We see it happens halfway between 0 and pi at pi over 2. All right, and last but not least, we want to know the inverse cosine of -1/2, or the angle between 0 and pi, so that when we take cosine of that angle, we get -1/2. And that angle is theta equals 2 pi over 3. Okay, so the inverse cosine of -1/2 is 2 pi over 3. If you're not sure where this comes from, we can either use the graph, or if you like the unit circle, where cosine represents x values. We look and see where in this region between 0 and pi do we have cosine or our x value equal to -1/2. So I'm going to dot that in here. We still need to know some stuff, but we know that our x value is 1/2, and that makes this reference angle pi over 3. So we see we have this larger angle in here. I'll draw this bigger. Okay, so if we draw our unit circle, we have cosine theta equals -1/2, so we're -1/2 to the left of the center. And we can think of drawing in a right triangle where this labeled angle has angle pi over 3. If we were to go halfway around the circle, we would be at angle pi. So we take pi and we subtract pi over 3, and that gives us the angle here of 2 pi over 3. Okay. So we're taking the angle at the x-axis and subtracting away our reference angle to find what this angle is. It's 2 pi over 3. Good.